Hi, folks. Welcome back to Source by Cofactr, the show that cuts through the noise and gets to the good parts. I'm Ed Dodd. Great to have you joining us. When we hear about production lines going down, our immediate instinct is to look right at the factory floor, as if that's where the problem is. But I think we all know by now that 80 to 90% of line stoppages aren't caused by the floor, they're caused by materials. We tend to think, oh, another material shortage, but often the real reason the line stops dead in its tracks is actually a mismanaged process that happened much earlier and maybe even miles away. So today we're going hunting for a hidden bottleneck in manufacturing. We're exploring the operational realities of EMS and the invisible trap of poor kitting. It's such an overlooked trap, honestly, because it is incredibly easy to blame the EMS for a missing part on a circuit board assembly. But that missing or incorrect part on the floor is almost always the final symptom. It's not the original disease. We have to look upstream to find the real root cause. A manufacturing line is only as reliable as the material kit handed to it. Let me ground this with an analogy. Imagine you've ordered this massive, highly complex piece of IKEA furniture. Oh boy. You clear your Saturday afternoon, open all the cardboard boxes in your living room, and you're ready to build. But instead of a perfectly organized package, you realize you're missing crucial screws, the worst feeling. And the instruction manual is for a completely different model. Plus, half the wooden dowels belong to a coffee table you didn't even buy. That is a nightmare scenario. And if you fail to build that couch, it isn't because you're a bad builder. You just received a disastrous kit. In manufacturing, handing an EMS a bad kit is like handing you that chaotic IKEA box, but on a scale that costs thousands of dollars a minute in lost productivity. That visualization really captures the friction. We need to define what a build-ready kit actually is in this high-stakes context. A true build-ready kit requires the exact right components, matching the correct engineering revisions in precise quantities. It also requires accompanying documentation, immaculate labels matching EMS expectation, and flawless timing. If you're missing any single one of those elements, you don't have a kit, you have a puzzle. And a puzzle is a terrible thing to hand an optimized assembly line. Though before we can even talk about fixing a broken manufacturing process, we have to look at the reality of this handoff. Just because a kit physically shipped and arrived at the EMS dock doesn't mean it passes the only test that matters. The true test is whether the EMS can receive it, verify it, and build from it without stopping to interpret, correct errors, or chase down missing information. Every minute an operator spends deciphering a faded label or walking down the hall to ask an engineer a question is a minute those million-dollar machines are idle. Okay, let's unpack this. Isn't putting parts in a box a pretty straightforward physical task? You would think so. We've been putting things in boxes since the dawn of commerce. Why do so many sophisticated organizations still treat kitting as just bulk aggregation plus a shipping label? What's fascinating is that the physical simplicity is the trap. It looks easy, just put the blue widgets in the brown box. How hard could it be? Right. But when an EMS complains about bad labels or unusable parts, they're not describing a warehouse execution failure. They're describing a failure of upstream design. Upstream design? Yes. Kitting is actually a complex engineering and data management process, masquerading as a warehouse task. You're translating a theoretical concept into physical reality. You're translating a technical document, the BOM, the bill of materials, into a physical package that can be consumed without thinking. Without thinking, that's the key. And when organizations treat it like bulk aggregation, just throwing components together, they force the factory floor to do the thinking. And paying production lines to think is incredibly expensive. They're there to build. So if treating kitting like bulk aggregation creates a puzzle, the only way out is establishing unbreakable rules. You have to eliminate guesswork. That means moving away from the illusion of the simple box and establishing strong standards. And the first principle is absolute. Completeness has to be binary. There is no gray area. A kit is either 100% complete and build ready, or it is formally released with documented, pre-accepted exceptions that everyone agrees on in advance. Otherwise, you're throwing a wrench in the gears. Fixed or partial kits burn line time and force operators into detective work. Expensive detective work. That's exactly what it becomes. And BOM alignment cannot be fuzzy. You can't build from last week's spreadsheet or grab a reel of components just because it looks close enough at 6:40 p.m. on a Friday. We hear so much about ECOs, engineering change orders. If engineering updates a design, but the warehouse is still packing from old data, you've just created a physical failure. The disconnect between digital data and physical inventory is catastrophic. Look at the Boeing 787 program. They suffered severe kitting problems tied to getting the right parts to the right place on the assembly floor. And the fix wasn't better carts or faster warehouse workers. It was a system problem. The problem was the data feeding the system. They had to redesign BOM management software and planning processes. Because if the software doesn't perfectly reflect physical reality, a cart arrives missing a critical bracket and mechanics are stuck waiting. The data has to mirror the physical world, and that extends to labels and documentation. In high reliability environments with traceability requirements like aerospace or medical devices, a label isn't decoration, it's operational control. If traceability is missing or documentation for a substituted part isn't attached, the kit is unusable. An undocumented part might as well be an empty box. But none of this matters if companies ignore the rules under pressure. A standard without enforcement is just a suggestion, and suggestions get ignored when deadlines appear, which is why release gating needs real teeth. No kit should ship if anything is unresolved, because catching problems early avoids premium freight, schedule churn, and downtime. And this brings up system optimism. System optimism is another silent killer. It's when your ERP says everything is fine, but the physical shelf tells a different story. Everything looks good on screen, so planning releases the build order, but the bin is empty. Inventory record inaccuracy, the oldest failure mode in manufacturing. And it happens because we trust systems too much, but the system only knows what humans told it. If someone used parts for a prototype and didn't log it, the system becomes optimistic and reality becomes broken. So companies need formal escalation paths. Otherwise, improvisation just flows downstream to the factory floor, which raises the question, what happens when pressure forces flexibility? Here's the tension. I want to push back on rigid controls. Doesn't strict gating risk stopping production entirely? It sounds extreme. If we're missing one capacitor, shouldn't we just borrow one from another order to keep the line moving? That feels heroic, but it isn't flexibility. It's just moving the problem, like taking a gear from one clock to fix another. You're not really fixing anything. You're risking future failure. So verifications need to happen at multiple stages: picking, kit completion, and handoff. Nobody should have to be a hero. And if a company realizes it's been running on confidence and vibes, and realizes they don't really have the expertise or the discipline, usually they hit a wall. At that point, outsourcing kitting becomes a serious consideration, not as a labor decision, but as operational maturity. Triggers for outsourcing include weak BOM control, messy inventory data, high mix production, or new product introduction, NPI, where designs change constantly. In those conditions, outside partners stabilize flow, like hiring a CPA when taxes get too complex. You don't hire them to type numbers, you hire them for enforcement and discipline. So, what does a partner like Cofactr bring? We bring repeatable standards, documentation hygiene, and controlled handoff designed for EMS consumption, not internal convenience. We act as discipline, stopping bad kits from ever shipping. So, pulling it all together, poor kitting isn't a warehouse problem. It's a handoff quality problem. If you don't enforce binary standards and strict controls, your EMS spends its time doing expensive detective work instead of building. And that cost shows up everywhere. downtime, rework, and delayed time to market. And this isn't just manufacturing, it applies everywhere: software pipelines, hospitals, any system where work is handed off. Garbage in, garbage out is universal. The quality of output depends on the quality of input. So the real leverage is protecting the handoff. One final thought. A physical kit is essentially compiled code for a factory. So what happens when AI starts validating these handoffs in a digital twin before anything physical exists? Could we reach a point where your system knows a screw is missing and fixes it before shipment? The boundary between digital BOM and physical kit is going to blur fast. It will redefine what a handoff even is. It's a fascinating direction to watch. Thanks for joining me today. Keep questioning the systems around you. Demand better handoffs in your own work. And we'll catch you next time. Thanks for joining me on Source by Cofactr. I'm Ed Dodd. I hope we cut through some noise and helped you get to the good parts. We're really excited about our new PaaS service model. It's free to try, so check it out today. If you found this episode valuable, please subscribe and follow Cofactr as we continue to revolutionize electronic hardware.